Okay, here we go. Convergence, Oceanic Continental. Now, take breaks here and there. Don't try to do all of these in a row. This is chucking a whole lot at you. Um, those three were divergent. Those were all spreading. Take a break. Now we're going to move into the convergence. What happens when when two plates are coming together? And we've got three different scenarios. We've got one where an oceanic plate and a continental plate are coming together. We've got one where two oceanic plates come together. And we've got one where two continental plates come together. And we've got to be able to identify all of these, which I understand is a big ask, but it's you know that's why we're here. It's one of these things. So convergent, oceanic, continental. Let's start. I'm going to on this side over here start with our oceanic crust. If you remember drawing that on the last one, it's thinner. So we're going to draw it thinner like this. What happens if this is moving that away into thicker, not eraser, into thicker continental crust? The kind of textbook example that's in like every geology book is this is South America. I'm going to learn to spell any year now. Yeah, so this is the west coast of South America, making over here more waves. The Pacific Ocean. So what happens is this plate is moving towards South America. Well, the density idea is going to come into play here. Remember, I said that would be important. Which crust is more dense? That's something you got to know, but you don't really have to know it because it's always available on your reference tables. Oceanic is 3.0, continental is 2.7, so oceanic is more dense. Go back to very early first quarter of Earth science. Things that are more dense, what do in terms of rising and sinking? Well, they sink. So this more dense thing, when it runs into this less dense thing, is going to sink. And the fancy term we have for that here in earth science or here in geology is called subduction. And I should have given myself a little more space, but that's okay. All right, so that is referred to as, I'm going to sneak that word in there if I can. Subduction, Duction, or a subduction zone, this will sometimes be called. Whoops. All right, what happens as it goes down there? Um, Chemically, there's going to be some water involved in the crust here. It's also going down to where it's hotter. You're going to start to get some melts. We're going to draw that in red because red's hot, right? So this plate, as it subducts down into the warmer asthenosphere, is going to start to melt. Surprise, surprise. And what happens is that I'm drawing these accurately. I mean, considering my artistic abilities, we call these plumes. They look like these like kind of upside down balloon shapes, upside down teardrop shapes of magma will melt their way right up through the crust and eventually make it right to the surface where they will pop their way right out. And when we see magma coming out of the crust, we say, hey, that's a volcano. So what this builds is volcanic mountain chains. And they'll get bigger and bigger and bigger as the volcanoes continue to go off and bigger and bigger and bigger and bigger, right? There's also, because there's pressure here, like this doesn't get a free ride just sliding right up over the top. There's some pressure in the crust. It's smushing. And if you take anything and smush it, like this, a tendon sheet, as you smush it, it starts to crumple but thicken, right? Um, that happens here too. And as that magma continues to melt through, you get volcanic mountains. So this is a volcanic mountain. If you know your geography a little bit, where you see this, like again, your very simple uh, type section for this is the Andes Mountains, which is the west coast of South America. Let's look at it over here. That blue line is subduction. There's a mid-ocean ridge. We did that in the last notes. This whole plate is moving that way. Did I do that right? The camera's backwards. This whole plate is moving that way. You can see these little arrows. That dark line right there is the trench. We're going to label a trench in just a moment, where the subduction takes place on that blue line. And then it's developed this whole entire mountain range through some of that crunching or folding and volcanic activity. Made of andesite, lo and behold. The Andes are, if you remember your igneous rocks. Okay. Let's label a trench, and then I don't know, we're getting pretty close to wrapping this one up. That right there is going to be a very deep part of the ocean. So it's actually like offshore. It gets very deep and then comes back up a little bit because of that trench right there. Subduction, melts, volcanic mountain. I think we got it all. So this is, let's just say, in case it doesn't say Andes, this is like the west coast of South America. We've got this on a smaller scale, but it's still very relevant. And if you have Mr. Ruddy, talk to him about the Cascadia earthquake. He loves reading about this, thinking about this. That this little plate right here is subducting underneath Washington and Oregon. Certainly led to volcanoes in the past. Mount St. Helens in the early 80s, maybe even just 1980. You can see these snow-capped mountains up here, volcanic, with cities right next to them. So we've got a volatile section of possible earthquakes going along with that subduction, with volcanoes happening here, and large population centers. Perfect recipe. But again, all thanks to subduction. So maybe I'll just throw that in there. I don't think I put Cascades on the quiz, but Cascades Mountains, which is in our Pacific Northwest. All right, sound good. Bell rang. We'll see some of you live in a minute, and we'll do these other ones. We'll keep on pushing. Thanks, folks. Keep it up.